Hello everyone, good morning. Today we are going to discuss Docker. Yeah. So welcome to this video, and today we are going to discuss how to use Docker, why Docker is getting used, and then we'll look into the hands-on of how to use Docker to build and ship your applications. So before we jump into the video, this is the what we're going to cover in this video. First going to look into the introduction part of the Docker. Then we'll just deep down into what are the deployment challenges which people face while building and shipping solutions and softwares into the production. That will help us in understanding what is Docker, and then what is the difference between virtual machine versus Docker. Then we'll look into why Docker is needed, right? Then we'll deep down into some of the architecture of the Docker. We'll look into some real life use cases of the Docker. We'll go into the setup and installation, and last we'll look into the hands-on part of Dockerizing and Streamlit app, right? This is going to be like an app which we build in local, and then we'll build it into a Docker container and then ship it. So that's all we're going to cover in this video. If you want to know how to build this app in the Docker, how to use Docker setup, please watch this video till the end. Okay, let's get started. So the first thing is, what are the different kind of deployment challenges which people face while building any software? So first one is it works on my machine syndrome. Okay, as you can see and guess from the word itself, right? And this is the major challenge which most of the developer faces. It works on my machine, but it's not working in stage or in a production environment. Or this software piece was working fine in my local, but now it's not working in when I'm trying to deploy it in another solution. Okay, and that's a major problem, and the major reason is different kind of environments has different kind of setup, or probably different environment is there, because that might not be present when you're building a particular software, and that can lead to the app is not working or performing as it should be, right? And if you want to understand the whole life cycle of a software, look into this, right? Like, first you're going to build an application, you're going to write a code, then you're going to test it in the development environment or maybe in your local. When you are going to test it in the testing kind of environment, right, where you're going to validate not even only the code, but you're going to look into the functionality testing. Then you're going to deploy that code, and then you're going to monitor how it is performing in production, and if anything goes down, then you're going to take it as a step towards finding that bug, solving it, and then resolving that issue. And this goes on, right? And that's why you need certain automation and certain system which can help you to do this thing much more faster. Also, another problem that can happen here is different kind of libraries and different kind of softwares that is getting used. There could be mismatch of that, right? And because of that, your code which is working perfectly fine in your local machine might not work outside of this. And major challenges like, when you're building any solution or any app, it requires a lot of different kind of complex softwares, packages, dependencies, right? Sometimes you're looking for database, sometimes you're looking for a particular API that can be called, or you're looking for some underlying operating system on which you're building that particular application, right? And those things might require different kind of configurations, runtime packages that needs to be installed manually, right? For example, if you're building any basic ML package, you might require specific packages like scikit-learn, TensorFlow, PyTorch, right? And then you need to install them. If there is any kind of error in installing that packages, it can lead to an error. Also, when you can see that, right, all these steps are manual in nature, that means someone is actually performing it, so it prone to a lot of human error, and sometimes it's hard to replicate. You might have heard of it, right? We have got a bug, but we are not able to replicate it because the kind of environment in which that kind of bug has come, you might not have the same kind of environment or the condition set up. So this is again another kind of deployment challenge which is being faced quite frequently. as we have discussed, right, like many people uses different kind of laptops or systems to build their application. Like for example, I'm using Mac, but somebody might be using Windows, somebody might be using Linux kind of OS, and you are using a different kind of operating system to deploy your app, right? Somebody might be running it in Linux, somebody might be using that application in Windows. So to have that OS specific behavior, can you need to be very sure that your application works really fine in different kind of operating systems, and that can lead to another kind of challenge, how you're going to build softwares which is OS agnostic. Also, it's very hard to port any application which you have built just on a one particular operating system and then you want to migrate it and run it in another operating system. Testing these kinds of applications requires some kind of resources, right? Like for example, you have built an LLM based app and you want to train it, right? So you're using some GPU machines, but at the same time you are using some analytical software which you have used for tracking, right, or for building any dashboards. Now if you're running both of them in a single machine, you need to have different kind of compute resources, and you might end up using both the resources, and might be your ML system is working but then analytical app is not working, and vice versa can definitely happen, right? And then the overall cost of running those applications might shoot up, and you will have different kind of challenges in making sure that you're able to run different kind of use cases in a single system or single hardware. So these are the different challenges which is there while deploying or testing out your applications. Lack of isolation, as I've just discussed, right? When you're building a one particular app, it might require different kind of solutions, and if they are not isolated, one particular error can lead to another software or piece of functionality not working, and it can lead to complete failure of your applications. Also sometimes it can lead to the security risk as well, and resource conflict, because all are running in a single system. Scaling is a very tedious task, right? Now imagine you're running all this manually, setting it up and making sure your application is running in a one particular system, and you want to scale it for thousands of customers. You have to replicate the same kind of effort manually, and it is very hard. Like you can imagine the amount of effort would be required to scaling it up all would again be quite manual and tedious. It can slow up your scaling part, if you want to scale your business, even if you want to scale it from an infra side, it could be lot tedious. And last, what about the rollbacks, right? Like if something goes bad in production when you're deploying, let's say, a new software release, and if something breaks, how you can make sure that you roll back to the previous stable version in a fraction of a second without impacting your production. These are the major challenges which you're going to face when you have to deploy any software. For that, what we have is Docker.
Just a quick note, Analytics Vidhya has 100 plus free courses from beginner to advanced on topics like machine learning, generative AI, agents, etc. Complete with certification. Click the I button to explore now.
Yes, Docker allows you to have this thing where you can develop applications, write your code in a particular environment wherever you want. Then Docker provide you this functionality where you can ship your application, package it really well, and you can share it with anyone in the world. Then you can test your application, right? So you also want the same kind of environment and system where you have built that app kind of application, you can even test it. And last, you can seamlessly release and deploy your application into the production without even worrying about how it is going to run in production. So Docker is an open platform for application development and deployment. It also works as infrastructure as code, and we're going to see what is infrastructure as a code. It supports your CI/CD pipeline, which is continuous integration and continuous deployment. It is faster code to production, right? It manages all the different kind of overheads that we have discussed, the challenges which we have discussed previously, and it allows you to write code faster, and put this into production faster. It's portable, efficient, and automated. That means you can build anywhere, you can ship it anywhere. Like, you don't have to care about the platform and the infrastructure. So before we jump into how Docker works, how we can use Docker to build our application and ship them, first let's understand the basic difference between Docker and virtual machine. So how does virtual machine works, right? And if you want to look into, just to give you an example, right? What is virtual machine? So virtual machine is any kind of machine, or is it like a system that you can access it virtually. That means if you would have logged into somebody's system remotely, that you can treat it like a virtual machine. Let's say when we log in into any operating system, which could be Linux, Windows, and any other, and we go to the cloud, right? And someone would have run that machine, and we can log in from our system by not even physically there. Like right now, you might be watching it in your mobile phone or your laptop or your desktop, right? That's an actual hardware, because you have the CPU, monitor, everything running, and the hardware, software, everything is with you. So when you're accessing it, it's not virtual. But now let's say you can log in into any machine or a system from your desktop or a laptop, and can access and run any software, or watch any video, or run any code into that system which is running somewhere remotely, right? Like it could be anywhere in the world. That is like a virtual machine basically, right? And virtual machines are basically used so anyone can access any kind of resources, even when they're not having physically access to that machine, right? And yeah, like those who we have worked on virtual machine will understand it much better. And just to give you another example, right, you can think of many people have done it before. When we run different kind of operating system in a one particular machine, let's say in my PC, I can run Windows and Linux OS at the same time. Why you will do that, right? And there's a various reason, because different operating systems might support different kind of application that is required for the businesses. Let's say I want to use Microsoft Office, so I need Windows, but at the same time I need to run some of my ML or analytical software, which are maybe a GPU based application which can only run in Linux, right? Or I have specialized software which only runs on Linux operating system. So what I can do, I can install both the different kind of operating system into my machine, into my laptop or a desktop, and I can log in into that virtual machine. When I want Windows, I can log in into that. When I want Linux, I can switch that, right? But what is happening behind that, right? If you look into it, there's a hardware component, right? Like you have in physical hardware, which is your operating system that is hosting on top of your hard disk, RAM, right? And whatever processor you have used for the system. Now that operating system on top of that host operating system is going to talk to your virtual machine or the guest OS which you're installing, right? So for example, you're installing Windows, and at the same time you have installed Linux on a particular machine. There's a hypervisor who is going to make sure that you can communicate to both the OSs. So basically what is going to happen, you're going to partition your hard disk and RAM accordingly. Let's say you have 100 GB of space, so you're going to give 50 GB to one particular OS, or 50 GB to another OS, or you can do it vice versa, like, or maybe differently, like you can keep it 40 60, 30 70, like that, right? Basically what you're doing is you are partitioning your resources to different OSs, and different application can access that much resource only. What is going to be the challenge in this, right? Your one particular VM can only have access to that particular resource. It cannot have access to another OS, another resources. So if you run out of memory on that particular OS, you have no other way either to repartition them or use some external hard disk, right? Same with the memory, you can't get more memory. And that is the biggest challenge of virtual machines, where let's say if I'm running one particular applications which might require few GBs of memory, and there's another application which sometimes require few GBs of memory, but during some load and some batch when I'm running in night, it require more resources. Now I cannot cater them at the same time because I have already partitioned 50-50 of my virtual machines, so I cannot give them more than the 50% of resources, even if it is ideal in another OS, right? So I hope you got the gist for that. But Docker solves this problem really well. How Docker solves this problem? Basically, in this, we are not having this partition of the physical resources. So how that works, let's say you have one particular hardware, you have operating system on top of that, there is a Docker container that is running. Now in that Docker container, you can have different kind of containers that is floating and running on top of that engine, like container. Sorry, your Docker engine can host different containers. These containers can have different kind of application and configuration. So for, let's say, you can run a Linux kind of operating system and an app which supports Linux, right, inside this container. At the same time, you can use a Windows kind of operating system and the Windows app that you want to run on top of that. You can do that, and both can run at the same time. Now what benefit this will have is, this is like, you can think of these as a container, but they are fluid in nature. If you want, during runtime or when you're building this containers, right, you can increase the size of these containers. You can use it. If they want more resources, you can allocate them. You don't have to go for the again partitioning them when you are doing it as in virtual machine, right? So that's a basic and biggest challenge when you're using virtual machine, that the resources are constrained. It's strict to that OS, where containers are not OS agnostic. Like they are basically do not depend upon the base operating system on which your system is running. They generally works on the application layer, whereas virtual machine is the virtualization of a OS plus application, whereas containers are basically virtualization of your applications layer. This, I hope that gives you the clarity between the virtual machine and the Docker, and that explains why use Docker, right? Why Docker is so much powerful than just using a virtual machine. But that does not make this that there's no virtual machines getting used and you don't need virtual machines. Virtual machines are useful, but Docker gives you more flexibility, and that's why you see that we are using Dockers in most of our applications because it gives you that flexibility and other benefits as well, which we are going to see now. Why use Docker, right? So if you see this, Docker containers provide isolated environment and application, as we have just seen, right? The Docker engine provides you that functionality which isolates the OS. Also, containers are lightweight and efficient in use. So they are pretty much lightweight as compared to actually deploying a complete operating system. Secondly, independent, right? Like containers eliminate this dependency on the host that we have seen. So you can independently run any application, any kind of dependencies if you have, right? You can just run that inside that container. Everything is packaged inside it. You don't actually have to think or maintain them separately. Concurrency, multiple containers can run simultaneously. Virtual machines, you could have run two, three, like it's very difficult to run a lot of virtual machines in a single system until like you have very big system which can handle a lot of things. But again, that's a biggest challenge because you have to maintain them and manage them manually. Where here you can run as many containers as you want and your system can support, and you can concurrently use them, run them, right? You don't have to just say that I can just use one OS at this point of time. Like if you as a user can run both the containers or multiple containers at the same time. Consistency, this is the biggest thing if you can think of, right? Docker ensures consistency across different environment. If you're running a particular container in a Mac OS or a Linux OS or a Windows OS, it is not going to have any kind of error because it's a container, right? Whatever inside it will get executed seamlessly. And shareability, you can easily share the containers to outside world, and we're going to see that how you're going to use the Docker and share your Docker images outside. So that's pretty much covers like why use Docker and why Docker is very much powerful. Now let's go into a little bit of the Docker's life cycle, right? And if I talk about, right, Dockers provide you the tooling and platform to manage the containers, right? So basically, as I talked about, now everything is like a container. Basically your app becomes gets exploded inside a container, and then everything is a container basically. Now you can develop your app and its component inside a container. So basically containers become a host for your applications to run. Containers serve as the unit for testing and distribution. So basically containers help you to test your application and distribute it. Now deploy containers, you can basically deploy your containers in any environment, like you want to run it in your local data center, you want to run it in some cloud platform or some kind of hybrid infrastructure. It will work exactly the same. You don't have to worry about it. Also it works as we have discussed, right, like based on different operating system or even any cloud platform, it works same. And if you look into this part, right, these are the basic functionalities of a Docker. It provides you the development part. You can build the containers, you can ensure that the containers functionality remains same, you can distribute them anywhere, you can deploy that in various kind of environments, and then running containers consistently across environment. You can run multiple containers at the same time. Now let's jump into the Docker architecture overview, right? So if you see, Docker follows a client server architectures, as you can see from here. And some of the major core components of Docker, first one is Docker CLI, like, client interface, line interface. The second is the Docker daemon, right? The third is the Docker REST API, then the Docker runtime, and the Docker registry. If you just look into this architecture overview, right, as we have just discussed, the Docker basically is an application which runs on top of your host operating system, right? And not only that, it is going to run a server inside it, right? This is the main core server, and there are Docker application basically, right? The client is interacting with using the REST API, and everything runs inside this container, inside this server, and basically all the containers and images that are getting formed runs inside it. Now this application manages images and containers. So we're going to talk about that, what are Docker images, what are containers in some time. But just think of like images are some runtime file and instructions which Docker follows, and based on those images and instructions, it is going to create that container when you execute that and run it. So image is basically, it's like set of instructions which it just memorized that this is what we have to do. It follows that and creates a memory map, and then when you execute it, run it, it creates a container in which the applications run. Now that there are two things which you're going to which you're looking here, we'll go into more detail in our next slides. One is the data volume. Now as you can see, like Docker is running inside all the containers and everything is running inside this server. It needs to communicate to outside your system, right, the host OS. For that, if it needs to communicate to an external space, right, let's say a particular folder, let's say E drive, C drive, or if you need to access or manage to a particular port, let's say you're running an application inside this container, but how it is the host OS is going to communicate with that, you can manage the network and data volumes using this. So this is the overall architecture of the Docker. Let's jump on to the official documentation of the Docker, right? If you go and search on the Google Docker, you will get this official website of the Docker that gives you what is the Docker, how to use it. And once you go into this, docker.com, you can see, you can learn how to use Docker, what are the different things Docker provides you, right? Like it can tell you what is Docker. Docker helps build, share, run, and verify applications anywhere without tedious environment configuration and management. And this is what we have discussed so far. It helps you how you can build a Docker containers, how you can share it, how you can run it, how you can verify it, how you can test it. All these things are provided to you, so you can do that. And you can see it is being used by almost 20 million plus monthly developers, 7 million plus applications, 20 billion plus monthly images pulls through the Docker, right? This is a huge number and industry-wide use tool. Now let's go into the documentation of the Docker, right? Like how, the first one is how to get Docker, how to install Docker, right? If you go to this docs.docker.com, or even if you are here, you can see how to download, like get started, how to download it. So you can just simply download, it's an open source. So you just come here, then based on your operating system. So if you have a Mac, you can click on Mac. Now you can again, Mac gives you different kind of OS chips, right? Like if you have an Apple Silicon one, you can choose this. If you have Intel chip one, you can choose this. And if you are having a Windows operating system, now again, based on that, what kind of OS you have and system you have, you can choose to download the Docker application directly. You can, even for Linux, you can run it and you can download it. Now once you download this, you can follow steps and then you will be able to download this Docker. Once you download this, you will see this, your Docker will come as an application. As you can see here, I have already downloaded it, so I have this Docker applications already there. It will take some time and it will load. And if you can see, there's an icon showing at the top, Docker running in resource saver mode. So if I'll go to the dashboard, you can see my Docker app is here, and it can show you what are the different images I have and it in running, what is the container that is already running, what are the volume things. So we are going to come to all this thing a little later on, but you can just download your Docker and just run it and start it. Now coming to the Docker, right? Like the Docker platform and the architecture which we were talking about. So let's look into this architecture. Docker allows you this kind of setup as we have discussed, right? Where this is the host, where this kind of app, this is just an application, but this is running something in the backend, right? So this is the host which allows you, the daemon is running. Now when I started the Docker daemon started, and you can see here, right, like Docker desktop is running. I can pause it, restart, or even quit the app, and I can close the Docker. This daemon talks to the client, right? And client is that interface. Either it's a CLI, right, like command line interface, or is this application, which is again a client. So basically Docker desktop is nothing, but it's like like an interactive tool which I can communicate to the Docker daemon. I can write some commands through my command line interface, or I can use this application to send these commands. What Docker daemon do, right? It understands that there are going to be two components for me. One is the images. So all different kind of images, basically the instructions and things which we are going to talk about later on, it communicates to those images and build those images. And once I write the command, it runs the Docker containers as well, right? And now this not only runs internally, it communicates to the Docker registry, right? As you have just seen right now, that these were so many containers and images that has been built historically. All these are available in the Docker registry. If it's a public Docker hub, then there's a Docker hub that is there, which is a public domain. You can maintain your own registry and images internally as well. Now all these images are present. You can pull those images and run it. If you have some images that you have built, you can push them back as well to the world. So basically Docker uses a client server architecture. Docker clients talk to the Docker daemon, which does this heavy lifting of building, running, and distributing your containers. Docker client and daemons can run on the same system, or you can connect a Docker client to a remote Docker daemon as well, right? Like you can communicate to outside as well. Docker client and daemon communicates using a REST API over a Unix socket, right? Basically, that's where we have talked about. Another Docker client is a Docker Compose and lets you work with applications consisting of set of containers. So if you have more than one containers, then Docker Compose is being used. What are the major components of this Docker architecture? As we have just discussed, right? The Docker daemon, and also called as Docker D, which listens to your Docker API and manages all the different Docker objects, such as images, containers, network, and volume. Another is Docker client, right? Like this is a specific client which you give as command line interface and it communicates to your Docker daemon. Docker desktop, right? We just saw that, like this is the Docker desktop application which allows you to talk to your Docker daemon. Another is Docker registry, right? I can take you to the Docker registry. What does the Docker registry looks like? Docker registry, and this is the official Docker Hub registry, right? You can see this is the Docker Hub, and there are multiple images of different kind of applications that you can think of, like for example Python, PyTorch, Redis, Postgres. Like you can think of any tool, software, or application, you will find those images here. So basically, Docker registries allow you to store the Docker images, not only store, pull those Docker images and use it for your applications. Okay, these are the major components of the Docker. Now let's look into some of the Docker objects, right? As we have discussed. So first Docker object is images. Okay, now before we go into the images, what does a Docker image, right? Image is nothing but it's just a read-only template with instructions for creating Docker container, right? You must be thinking like, okay, we are talking about like Docker images, but these are just a simple file. And exactly, yes, it is just a simple file with a lot of instructions that we might do manually. And I'll show it in the demo in a couple of minutes how to build a Docker image. And often an image is based on another image, right? Sometimes that's what we have discussed, right? You can run an Windows OS in a Linux machine. So from where that Windows OS will come, right? This is where you can pull that image. So that's what it is kind of referring. Often an image is based on another image with some additional customization. So let's look at an example, right? For example, you may build an image which is based on the Ubuntu image, but install the Apache web server and your application as well as the configuration details needs to make your application run, right? So what it is saying, you can pull that Ubuntu image, install an Apache web server, maybe build your Android or any kind of application on top of that if you have to run it, and then you created your own customized image. And then customized image, you can share it with anyone. Whoever will run that application will automatically have an Ubuntu server, an Apache web server running, and your Android application would be running on top of them. That's your customized image, right? So we'll look into this example just after this, and then things will become more clear. You might also create your own images based on that, and then you can publish them into the Docker registry as well, right? So anyone in the world can use it. So that's how it works. Each instruction in Dockerfile creates a layer in that image, and when you change the Dockerfile and rebuild that image, only those layers which have changed are rebuilt, right? So basically, whenever you're building an image, any changes that you are making, only that will be reflected, not everything in total. Another major object of of the Docker is container, right? That's what we were talking about so many times that we have talked about containers is nothing but an runnable or instance of an image, or like an executable instance of an image. When you run that image, containers get started, and whatever is running inside that container will be basically your application or the system that you have created. So basically you can create, start, stop, or even delete a container using your Docker API. You can connect a container to one or more networks. That also we have talked about, right, in our slide, where Okay, you're running a container, but then how you're going to connect to the operating system, how you're going to access it. If you want to store some data or read some data from your host operating system, you can attach and storage to that, right? All this thing can be done inside your containers. So containers is defined by its image as well as the configuration option you have provided when you starting it and running it. That's all. When a container is removed, any changes to states that aren't stored in persistent storage disappear, right? Like when you kill that or remove that container, everything that was there just goes out of that. And this is just an example how to run a container. We'll look into that in our uh, next section. Now, when we have looked into the Docker architecture, let's first look into some of the major components again of the Docker. So the first one is the Docker image, right? As we have talked about, so there are two major principles of a Docker image. One, the images are immutable, right? So once an image is created, it can't be modified. You can only make a new image or add a change on top of it, right? So basically you go back to that old file, make the changes, build that image again and create a new image. That's all you can do, right? Also, container images are composed of layers. So each layer represents a set of file changes that add, remove or modify file, right? So container images has that layer thing. Just to have as an example, right? So if you do docker pull or docker push any image name, you can pull and get that image from the Docker hub or any registry. Same way, if you want to push your image to any registry, Docker registry or Docker hub, you can use docker push to do that. Secondly, if you are building any Docker image, right, these are the some command line tools, and I'll show you in the app also how to do that. So if you run docker build dot, right, and dot means your Docker file should be there in that particular repository, or you can give an exact name also, right, docker build and -t, and then you give the image name, let's say my name and image name and dot, right, that will create a Docker image. That's how you can create a simple Docker image. Then coming to what is Docker containers, right? Containers, again, as we have already discussed, is an executable Docker image. It's self-contained because each container has everything it needs to function. There's no reliance on any pre-installed libraries or any host machine. Isolated because each container run its own isolation. As you can see here, they have a minimal influence on the host and other containers, so increasing the security of your application. Second, independence, like it can manage its own. Portable, so containers can run anywhere. So the same image, if you have built in your local, you can share it with outside, and containers that run on your local can run anywhere outside as well. How to run any image? You just define the docker run command, run it and define the port. Let's say, as I discussed, right, if you have to run it on a specific port and you want to open that port, you can define and do the mapping of the ports and then define the image that you want to run, and it will run that. Coming to what is Docker Registry. Docker Registry, as I just showed you, it stores and distributes your Docker images. Public registries like Docker Hub, which anyone can access and download it from here. Private registries are, there would be like, some GitHub, AWS, ECR, or some, you can have your own private repositories for your specific apps and solution that you have built. And command line interface can help you to pull and push your images to that registry. How to do that? Again, very similar command for docker pull and docker push. And at high level, Docker architecture, right? So basically these are the three major commands that helps you to run and build any image, any containers. First is docker build. Basically that allows you to build an image. Now sometimes you use docker pull to pull that image automatically that has been built by someone and you just want to use it. So you do this docker pull, and then another is docker run. Now if you see here, when you run docker build, this command line interface request goes to the host and it builds an image. That's it, right? You can see an image got built here. Is if you look at this arrow, docker pull command actually asks Docker daemon to go to the registry, wherever that registry is. If you have already connection set up, it will go to that registry and build that image for you. So now that image is coming up here and getting stored in your local daemon. When you say docker run and write the name of that image, it is just going to execute that image and then we'll start that container. This is how the flow works. To look into this, if you want to understand, now this is my container and this is my image. So if you go to any image that is running, you can see there are list of instructions that has been already set up and written in it. So these are the layers basically, right? Like first one, add this, run this command line. This is the environment setup. Copy this Docker file from here to here. Run this copy from, set up my working directory, and so on, right? So these are the some of the instructions that has been written in the Docker image. Same way, if you look at into the containers, you can get all the logs of that container. You can inspect and see what are the instructions that is there. You can see if there are some files that is there, statistics around the data from how much time it is running. Right now it's not in running mode. If I'll start it, it will get executed, and so on, right? So this is the difference. If I'll go to the Docker Hub, so you can go to Docker Hub and connect from here in your Docker desktop as well, and I showed you the image also how you can get it. Let's say if I am using Olama and I want to use this Olama image, how I can do, I can just pull this image, right? So I can run here, pull, click on it, it will start pulling it. If I'll execute this, it will pull and then start running it. And if I have to do it through the command line interface, how I can do, if I have to run it for CPU only mode, I can run it like this by after installing it and running these commands. So these are some of the basic functionalities of and things that is there for the Docker. Okay, now you must be wondering you must be wondering okay, now you must be wondering, we have looked into the architecture of the Docker, how to create Docker image, right? Like how to build the Docker image. And that's what we are going to look into it. So if you see now, what is Docker image? Before we jump onto the hands-on part, Docker image is basically a set of instructions, right? And this is how you can think the instructions are. The first one is from, right? So from image. Now this defines your base image. This is something which is very similar if you're pulling any image from a Docker Hub or a Docker registry. So what you can do, you can write like from and the image name. And that, let's say, for example, you want to pull a specific image for Python, right? Or you want to install a particular OS. Let's say you want to install a Linux OS, right? So you can just run this command and it will automatically pull that image for you. Okay, so this is the first thing, and this is almost the first command when you are creating any Docker image for your use case. The second command that is there is run command, right? This actually helps you execute any command in that layer, right? For example, if you want to execute or run something, if you want to execute a Python command, or if you want to execute some shell script, or you want to have some kind of commands that is required for your program, right? All this thing can be executable through the run command. The second kind of command is like working directory, right? So with this, you can set up your working directory and you can run any command inside it then, right? For example, run command entry point, copy, add instructions, right? To do certain things. So all the different kind of activity that you want, you can run it. So with this, you can set your working directory. Now this, you need to understand why working directory. Docker is going to have its own space, right? In terms of the storage, in terms of the file system, and the kind of OS you're going to install. Like for example, if you're installing in Linux OS, it is not going to have like a C drive, D drive kind of format. It will have the user slash the basic app or a root folder it will have, right? That's how generally you will see the kind of file system that generally is present. Now in order to access any file from there or copy your data, you need to know the file system. That's why you're setting up the working directory here. Now another kind of thing that is there is the copy command. Copy is going to copy some files from your local file system into the Docker. Yes, this is very much important because it is going to you need all the file system that you have, right? That you want to run. Let's say you want to run your Python file, which is abc.py. Now how Docker will be able to execute or run that Python file if you're not able to find it, right? So copy command will allow you to copy all the files that you have in your local to your actual thing that where you want to run it in the Docker image. Another kind of command that is there is command, right? Like this defines the default program that is run once, right? So this is like an entry point, and then it is the default kind of command or a program that you want to execute once you start the container. So this is the base. So each Docker file only have one CMD, and only the last CMD instance is respected with multiple exist, right? Even when multiple exist, only the last command is being used. So this is very much important, because a container is going to be an executable instance. If it is not going to execute anything or build anything, right, then yeah, it will just be a same container which has nothing to do basically, right? So in order to run your application, you need to provide the command at the end using the CMD command. So let's look at this one example we have. Right now we have this set of instructions, and with that you can see here at the right hand side we have a sample Docker file that we have built. This is a very simple Docker file that we have built here. Let's look into this one by one, and then we are going to execute this, and then we are going to use this executable file for our use case. So the first line, right, as it is mentioned, from Ubuntu colon 22.04, that means it is going to pull the Docker image of an Ubuntu operating system. So basically Ubuntu operating system is something which we are going to install as our base image, right? And then we are going to run certain commands on top of it. So this is going to copy Ubuntu file system or Ubuntu operating system into your Docker container. Second command that is there is install any dependency or app dependencies that is there, right? So basically what we are going to run here, we are going to run apt get update and apt get install Python, right? And then Python pip. So what we are installing here, first we are updating if there are any packages that is required in the Ubuntu file system. I am installing that. Second, I'm installing Python, right? Because if you have to run some Python script, or if you're running some app, building an app, what you need Python, right? That's what we are going to run and have that. Then we are installing pip here. This run pip install Flask, right? It is going to install the Flask version 3.0, right? It is going to have any advanced version, and that is going to be there. Then it is going to copy the file. So now what we are doing, we are copying the file hello.py into the file system. Then we are just doing the final configuration. Basically we are having that environment Flask app is equal to hello, exposing the port, and then the last one that we are running is we are running this Flask container on the port 8000, like 8000. We are running this on this. So this is just a syntax of one kind of Docker image that you can see. Even if you look into the Docker hub that we have, right? Let's look into one of the Docker hub image that we have for Python. So if you go to the Python, and you will find it, there are a lot of images that is already present. With this, you can even run in the Docker desktop, right? Any particular Python version that you want, right? There are multiple versions of Python that is available. You can pull it and you can run it as it is required. And this is a very basic, simple Python Docker file that is present. What it is doing, basically, if you see here, it is first pulling the Docker image. Then it is setting up the working directory. Then it is copying the requirement.txt file. Then it is installing all the packages that is present in the requirement.txt. Then it is copying all the files that is present in that local directory into the Docker container. And then last, it is running your Python script with the command prompt like cmd python and your whatever your script name is, right? Like the file name is, it is going to run that script. So this is how you can create a Docker image and can create a Docker container. So let's get into the hands-on part. What we are going to do, we are going to create a Docker file and then build a Python app using that. So for that, you can open any IDE. You can create a very simple Python script. So let me create a very simple Python script first, and then I'll show you how you can execute this Python script into to a Docker container. Okay, so before building a script, right, what we are going to do here, we are going to use either you can use Flask or you can use any other way to execute a Python script. For our demo, I am going to use a Streamlit based app. Okay, so what is Streamlit? If you want to know more in detail, you can Google it. You can go to streamlit.io and you will see that this is again a very famous package that is used for building and sharing your Python apps, and it has a lot of different functionalities. How to use Streamlit is a very simple way. Just import the Streamlit package, and then if you do Streamlit as st importing the package, and you can write you can create simple dashboards, you can create different kind of inputs for the users, like say an input box. You can create a simple button to get any action done, right? If you have to host any ML model, if you want to build an app that can be used for any kind of user interface, you can build that a very smaller app. Even you can build generative AI and LLMs kind of app here as well, but we'll not go into this detail. What we're going to do, we are going to build a very simple Streamlit app. So I'm using basic Copilot here, so that will help me in getting the work done quite faster. Build a simple Streamlit app, right? So again, a very simple app, let's say it's going to build. So now what it is doing, it is building a very simple Streamlit app. Let me walk you through the code. If you see here what we have built, we have a simple Streamlit as st. So basically what we are doing, first we are importing the Streamlit package. Now in order to have the Streamlit, you need to install that. So first what we are going to do, let me just rename this file. Let me create a Python file as app.py. Okay, and let me have this code here, app.py. It has the Streamlit app, and then what first thing is the title. So basically what we are creating here, we are giving the name of the title of the app. Then I'm writing here whatever the heading I want to keep, right? Like welcome to my Streamlit app. Then I have created a second input. So basically I am created an input that is st.text input, so user can give. So here if I'll put, it will ask me enter your name. If I'll give an input, whenever there is something like input, it will going to return it, and it will say hello and whatever you have provided that in the input. Let me show you how it will look like with the demo, and then we'll see how to access it, right? So let me open the terminal. Now in order to run the Streamlit app, basically you need two things. You need Python. So I already have Python installed in my system. Second, you need Streamlit package, right? So let me create a requirements.txt file, and I can create a dependency here, and I can write the package that I want. I'm not specifying the version here, but then it's good to specify the version that you want, right? So now if you see here, I have two files, app.py and requirement.txt. How to execute a Streamlit app, right? So first I need to install the package. So I'll run pip install our requirement.txt. And then okay, that is something you can run it, and you can see I already have the Streamlit package, so I don't have to do anything. So it's already installed. If you haven't installed it, it will ask you to install it, and it will install it. Now let's run this app. So I'll use Streamlit to execute and run this file. So this is the command that you have to pass, Streamlit run app.py. If you execute this, it is going to start the server, and it is asking me to allow to run this app. Now you can see this app is running on my local host 8501. Let me go towards this port, and you can see it. My application is already up and running. And this is the simple app that I have built, right? Simple Streamlit app. This is the heading that I have. Here it is the text that is written, welcome to your first Streamlit app. If I'll give my name, let's say if I'll give Ashish, call my name, hey hello Ashish, right? Like it is just giving me back the name that I have, right? So this is how simple it is to build a basic app that you really want to use it. Let me change it, right? Let me get some more input. So I'll give it as the name and date of birth and calculate age and use button to print the age, right? Like I have just asked basic functionality, you can write it, right? So basically what I'm doing here, I am using here two input. I am going to take the name of the person, I am going to get the date of birth of the person. Now based on that date of birth, what I'm going to do, I am going to calculate the age of the person, and then it will say, hey hello, your age is this, right? Please enter, or if it is not present, then it is going to ask us the input. Let me just refresh this, and you can see the first one, it is there. It is asking you to give the name of, I'll add my name, hello Ashish Park. Okay, it has not reflected. Let me update my app again. Yeah, you can see now it is coming up, right? My name is coming up. By default it is choosing this date of birth. I can define my name and let me calculate the age. It has automatically picked up the today's date, that's why the age is 0 days, right? Let me change this, let me make it, let's say 1990, right? Let me make it, and if I'll put this and click on calculate age, okay, I think it is not refreshing. Okay, I probably need to refresh this again, and let me change this to 1993. I hope this should work. Yeah, and I can give the name again. Yeah, and now you can see, hey hello Ashish, you are 32 years old, right? Like something like that, you can get it. So basically what we have built here, we have built a very simple app that we are running in Python. So you can see now, if you have to deploy this app, let's say, right, let's try to build some more functionality. If you really want, you can build some complex functionality if you want. Even you can build an ML model, so you can call any ML model, you can build a chat based app, right? You can build anything. But if you're going to deploy this app, there are few things that you have to do manually, right? So first thing is you have to copy this code with app.py requirement.txt file, and if you have any other dependencies, you need to copy this file and upload it somewhere, and then you have to execute it. Secondly, you need to have this requirements.txt file that you have. You need to make sure that it is running it, there is no incompatibility in the versions, right? That is there. And then second, you have to make sure that the Python version that you have, it's consistent, because if let's say I am running on Python 3.10 and somewhere it is like Python 3.12 or 3.13, right? Like as we have seen, multiple versions of Python can be present. It can actually impact your overall app, and it can probably break it, right? So let's say if I have to package it and share it with anyone, whoever wants to use it, then we need Docker for that, right? So everything is fine. You can think of, there could be n number of files here in this code, and I can run this in locally. How I can make sure that this code and this app is going to work seamlessly without any error or any kind of issue that can occur, and anyone can access this app, how we can share it and reproduce the same kind of results anywhere outside. So for that we have Docker, right? That's where the Docker is useful. Now how to create a Docker file? This is where you can see here, right? Like first we are going to create a Docker image, and then we are going to execute this Docker image to build a Docker image, and then we're going to run it into a Docker container. So let's do that. So first what I have to do, I have to create a Docker file, right? As you have seen it before as well. And you can see here, the moment I've created a Docker file, you can see the logo of Docker is already coming up here. So even the Visual Studio IDE is able to understand that this is a Docker file. And if I'll click on this, you can see this Docker file is present. Now what I am going to do, I am going to execute this app. And now you should remember what are the things that we need to do. I need to pull the image, official image, that it is now automatically recommending for me, right? Because the Copilot is enabled. But let's use this Copilot to build our Docker file also, right? That way I'll guide you towards how to do that, and maybe if any changes are required, it will be done. So pull the official Python image from the Docker Hub. I don't need anything. I don't need Ubuntu server. At least I just need a Python image, right? Because I need to execute this using the Python. But if you need Ubuntu, any other operating system, any other database, you can install all that. For me, yeah, I just need this. So it is automatically recommending import from Python 3.9 Slim, right? This is one of the Python version that is there. If you go back to Python images, you can find there are a lot of different version of Python is available. Let's say Python 3.14, 3.13, 3.12, like so on. There are different kind of Python versions that are available. Now you have to decide which Python version you want to use it. I can use Python 3.9, or even I can use 3.13, right? I can use this Python 3.1.3 version. You can see that, right? It automatically suggesting me, but let me hold on to that. Like you can actually see the code is coming up, but let's remember what we have. We need it. So we need to set the working directory, right, for the container. That's what we have already talked about. So we are setting up the working directory. Now I need to copy the requirement.txt file in this container, right? Because if you remember, right, when I executed this file, I created a requirement.txt file and I ran it to make sure that all the packages that is required for me to run this app is present, and it is like installed properly. So this is then after copying the requirement.txt file in this folder, I am going to run this pip install. So I am going to execute this requirement.txt file to install all the packages that is there. Then I need to run this app.py file using Streamlit, but then app.py file is not present because I have not copied that app.py file. And now imagine it could be like there could be hundreds of files that could be present for my app, because this is just a very small demo project, right? So in this I am copying all the files that are present inside my local into the Docker container. Okay, so this is how it is going to copy all the files. So copy ... is going to copy the rest of the application code into the container. I hope that makes sense. Now what we have to do, we have to execute this, right? This is the command part that we have already discussed. So cmd is going to execute this code. Now if you remember how we have executed the code, right, like streamlit run app.py, this is the same thing where the command line is going to execute, and we have divided this code and we are putting it under this list. So streamlit run app.py, that's all. But now what we are doing here, we are defining the ports also, right? Like server.port, and then I'm defining on which port I want to run it, 8501, right? And then the address is 000 because it's a local host where I'm running this application. Once you have built this Docker file, now let's build a Docker image. Let me check. I want to use this image, or if you are looking for any other specific image also that you can define that. I think 3.13 should be fine. Let me check it, or otherwise I can define and change it with 3.13 Alpine. Yeah, I can use it. You can basically use this and even refer this, right, like python from 3 dot, like, yeah, like I can use it anything 3.110, let's say. Let me take that. Okay, now if you remember, what are the commands that we had docker build, docker run, right? These are the two commands that we had. If you remember, docker build is used to build the Docker image. So if I'll do this docker build and dot because my Docker file is present in this particular folder. Let me do this ls for you. Right now you can see my Docker file is present here, app.py is here, and requirement.txt. In order to build the image, I have to run this docker build dot. If I have to give the specific name for my app, let's say demo app, so I can give for -t demo app and dot, and let me run this. Now you can see what it is doing. It is executing this command, so it is building this, loading the definition from the Docker file. Then it has started copying it. So basically it is pulling the image from the Docker hub. You can see here it is from docker.io library python 3.1 slim, and right, it is pulling this Docker image. Once this image is successfully pulled, it is going to set up the working directory. It is copying the requirement.txt file. It run pip install and install this, and then it has successfully even created the command for me, right? So command is going to execute at the end. All the 5 commands that I had, like this 1 2 3 4 5, all the 5 commands are already run for me, and it is successfully. So this makes sure that what are the commands I have created, it is running fine. If you want to see if my Docker images are running fine, you can go to this Docker images, and you can see now my demo app is successfully created. So I have this image ready. Now the Docker container is not running, my application is not running, but I have successfully created this image. Even if I'll go back to my Docker desktop and I look into the images, you can see earlier I had one for annotate. Now I have demo app that is there, and it is going to tell you what are the different layers that is present and how it works. You can see my image instructions are already there. Now let's run this. But in order to run this, you can run it in a multiple way, right? Like you can use this, you can push this to Docker hub. So basically you can send it and share it with anyone in the world, or you can run this. So if I'll click on this, it will execute it. But let's use the command line interface like CLI to execute our container and use that container. Okay, that will start this application inside the Docker container, right? Like my application Streamlit app that I have built. So how to run in a container? Basically, if you see here, docker ps docker run, and let me give the name demo app. That's all. Okay, my bad. Docker command was docker run demo app, and if I run it, you can see this. Now it has started this app, and it is showing me this app is available on https://:8501, and let me try to access this app here. And if I'll go to this, okay, it is not showing anything. Now this is strange because it is showing my app is up and running here, but it is not running. And you could have guessed it right? We have built this application inside the container. We are running this, but my operating system, like this laptop, does not know how to access to this Docker container. And if you want to see that the container is up and running, you can go to the containers also, right? And you can see here, it is using demo app image. It has created some app with the name, right? Distracted bench. Like if you want to give specific name, you can do it. And you can see it is already running it, right? It is in the running state, but it has 8501. But you can see here, right? That's the thing. Here in my container where I have it, that the port is already mapped, but I haven't mapped my port. And that is the biggest reason I cannot access this app even if it is running, right? And you can even see this is still, kind of in a running state. If I'll stop it, it will get stopped. And if I'll put a docker ps, there is no container it is showing. So if you see now, it is stopped, right? I need to execute this. It got stopped because it was not running. Basically it just started, but then I was not able to access it. In order to access this, what you need to do, you need to run this but you need to map the ports, right? In order to map the ports, you can use dp, and then you can define the ports that you really want to map. Let's say I want to map 8501 colon 8501. These are the port I want to map, and then let me run this command demo underscore app, and let's run this. Now you can see I have created this image, and if I'll go back to my container, and I can see here now my container is up and running, and even the port mapping is showing up. And if I'll go here, now you can see my app is running, and I can define the name, I can change this, I can make this 2015, and if I'll calculate, uh, it is not refreshed properly. Basically, if I'll change this to some 2026, not 2026, let's put some, and if I'll give my name, you can see here it is calculating the app, it is working fine. Even if you want to get the logs here, you can see here, okay, my app is running, you want to inspect what goes inside it, everything is available. You want to know the status stats, right? What is the, how much is the CPU utilization, how much is the memory utilization, how much is the network input output, right? All these things of details are available for you. Okay, so you can see here it got started, this is app is running. With this, you can actually run your app inside the container and can make sure that you are able to replicate the results, basically, right? And you're not going to impact any other person's work. Also, if you see here, right, when we have built this app, it's very simple. And if I'll show you Docker PS, you can see the container is up and running. So you can share this image and exit. So someone will have to just pull this image and then have to use it. If I'll go to Docker Hub and if I'll go to the image, you can see here, this is the image, and even I can push this to Docker Hub. Now again, Docker Hub push will require you to authenticate few of the things and then work. You have to first sign in, so people will know that, okay, what is the image you're trying to push, what is the use case, and a lot of other things that are required. But then it's very simple. Once you sign in into the Docker Hub, you can push your image and it will be accessible to someone whom you want to share. So that's pretty much about around the Docker. I hope you have got a high level understanding that we have already discussed. Uh, these are the commands that is required, and these are some of the commands that we have seen, right? How to build the Docker container, basically image, and then run the container, how to look at the Docker images that are running. If you have to stop it, then you can use Docker stop, or you have to delete it, you can just use Docker rm. And yeah, we have looked into the ML part. So that's it what we have for Docker. Thanks everyone, see you